Hi, and welcome to our talk on database observability for security purposes. I'm Peter Silberman. I'm the CTO here at Expel.
And I'm Dan Whalen. I'm on our detection and response engineering team.
Today, we're going to talk to you about a few things when it comes to database security observability. First, we're going to kind of level set on database monitoring and some trends that are really interesting and kind of have accelerated the use of database as a service and just databases in general. And we're going to talk about the observability data available, how we might leverage it, and then we're going to go into some specifics using MongoDB Atlas as kind of the exemplar. And Dan's then finally going to walk us through some attack scenarios. So why database monitoring as a thing? I think this is a fascinating topic because when you think about database management, it's come so far in really the past 5 years. If you think about 5 years ago, were you considering as an option letting someone else manage your databases, whether it's Snowflake, MongoDB Atlas, or any of the other providers currently running and scaling your databases automatically? Or were you thinking, I have to run it myself, maybe I'm lucky enough to run it on cloud infrastructure? And that's one of the interesting things is we've noticed that the database management and performance monitoring has come so far from the Nagios days, if you will. But we don't necessarily feel like database security, at least within the customers we talk to and how we look at it, has kept pace with engineering tech stacks and choices engineers are making. And so today we want to kind of talk about the opportunities we see for database observability for security purposes. But before we do that, let's move to why this is an important topic. Most of the time, databases are the final boss. If you've looked at headline grabbing breaches in the past couple of years, the last step in that attack life cycle or the chain is grabbing the data, exfiltration. And usually it's done by accessing a database for illicit purposes. And we don't see as many people talking about the opportunity to do database monitoring using a lot of the observability data that's available today that's kind of at your fingertips. And that's kind of one of the things we hope to leverage in this talk is we're not going to drift to bespoke data signal for database security. We're going to talk about some of the common things that we all should have access to because we're monitoring our database's performance and how we might leverage that. So we're always asking ourselves when we journey into a new space at Expel, what signals available? And I hinted at it just a slide ago that we think that a lot of opportunity exists in the kind of engineering and performance monitoring observability that databases produce and that most engineering teams have access to. And we think about our ability to leverage slow queries, spikes in disk consumption, things like that for other purposes like security and security monitoring. And that's kind of what we're going to explore coming up here going forward.
Yeah, just building off of what Pete said, when we think about kind of building a security strategy or detection and response strategy for a type of technology, it really starts with what sort of signal exists. And when we took a look at databases in general, we came away with these three high-level categories. You've got your metrics covering things from resource consumption to application usage, to how timing looks across your app. And this sort of data typically already exists in your environment, right? As an engineer, as you're building an app, you're incorporating these metrics into dashboards and making sure that you're meeting those uptime and SLA goals, if you will. The second big category we see is logs. So in terms of database technologies, you've got generally an authentication log, you've got an error log, often a slow query log, and in many cases, a more detailed audit log that you can configure for specific tables and things like that. Although we find that can be pretty expensive and often a little bit tricky to configure, often requires a little bit of a white glove approach, if you will. There are some other categories of logging as well. So, as an example, maybe custom logging from your application. If you have a security technology in your topology like a WAF, that can be a source of signal as well. But we really solve these big categories across all database services in general.
So I think everyone here has probably heard of the shared responsibility model when it comes to cloud infrastructure. It's a diagram that AWS made famous, but it at this point is well understood. We kind of in thinking about the database management or database provider layer, thought about it similarly in breaking out kind of what the customer is responsible for and what a database service provider is responsible for. So you can see the customer is responsible for the data, especially when it comes to queries. They're responsible for access management, network access, like the is this open to any, things like that. Sometimes they're responsible for the configuration, but I think sometimes that can also be abstracted away further, or recommendations can be made by the database provider as a service vendor. And then configuring backups is sometimes the responsibility of the customer, but you can also see it sometimes as a service provider. It depends on the provider. Encryption, these are usually checkboxes you have to turn on, but sometimes it can come default. Alarms and auditing. The database provider is really taking responsibility for the hardware, access to the database from a data center perspective, and additional software upgrades. A lot of times the provider will take that on, making sure that there's good APIs, making sure there's good logging, things like that. The database provider is responsible for all of that.
Yeah, one of the things I would call out here to build on what Pete said is, the service provider in this case is doing a lot of heavy lifting for you, swapping hard drives, handling the network stuff underneath the curtain and all that stuff. But some of what they're providing also represents like a net new attack surface, like things like their control plane, their APIs. These are things you didn't have to worry about at all in terms of observability or security controls. And now you do sort of have to think about managing that kind of access and that sort of risk with their SaaS platform.
It's a good call. Thanks, Dan.
Yeah, so we wanted to pick a technology and take a closer look at what security observability would look like as an example. Now, we think our findings will generally apply to most databases as a service, but we chose MongoDB Atlas because, first of all, it's sort of an up-and-coming popular technology. Just selfishly, it was very easy for us to get up and running and swipe the credit card and get a test environment up and running where we could sort of play out some of our theories and ideas and get a better understanding really quickly of what a detection strategy or approach would be for the technology. So this should look pretty familiar. We sort of applied this lens more specifically to MongoDB Atlas to get a sense for what sort of signal exists in terms of observability. Again, they've got all the metrics right out of the box. You turn on a cluster, you get all this stuff for free, right? CPU usage, disk usage, all that great stuff. You can easily hook that up to Datadog as an example, as you'll see that we did. They also have support out of the box for all these types of logging with a couple of checkboxes in their console. You can configure auto logging as well. And the platform actually comes with some additional sources of signal that you might not get if you were doing things on-prem. A good example there would be their project alerts. And additionally, their control plane, which is kind of the basis of their entire SaaS platform, it itself produces a source of signal that we can use for detection and response purposes. So we'll dive into what that looks like. Again, just quickly, here's a look at some of the metrics you can pretty quickly and easily configure right out of the box with Atlas. We got this Datadog dashboard up and running with a few clicks of a button, super easy to configure. And in the following sort of attack scenarios, we'll try to dig into how could we use this sort of data for security observability purposes. I mentioned the control plane. So out of the box, they have the capability of generating alerts and notifications for various things happening in their platform. For example, like users joining the project, clusters being spun up, all sorts of things that are happening in their platform. You can configure all kinds of events to notify you when certain events happen. Project alerts, similarly, you can do things like make sure all of your users have multi-factor authentication turned on and alert you if that's not the case. They actually have some built-in monitors looking for certain metrics exceeding certain thresholds. This is all stuff that's useful if you don't have your own APM solution. Just by getting their SaaS platform and signing up to Atlas, you get a lot of this stuff for free. And finally, we touched quickly on logging. Again, this is super easy in their platform. You see it's just a checkbox to turn on database auditing. You can get pretty granular with the specific audit policy. You can enable auditing on certain databases and collections, certain event types, and for certain users. So it allows you to granularly select what kinds of events you want to be logged, which is actually really important for this level of auditing because these logs are pretty voluminous, especially for a large production database. You got to be really careful what types of events you start to log. I think our test cluster that's just sitting there doing nothing was generating 300,000 logs or so a day. So just you got to be careful when flipping some of these switches. Absolutely.
So one of the things we find valuable when we kind of do this thought exercise of like what would it look like to monitor using observability data is really putting on the attacker hat and getting after it. It's a lot of fun to do that as well, and it really flexes a set of good muscles as you think about what can be attacked, how would you go about it, and then do you have the visibility to detect it. We monitor a lot of cloud environments on behalf of our customers, so we've seen a number of different ways to exfil data by red teams and attackers, and so we've gotten some experience watching what people are doing or trying to do and detecting it. And so we wanted to apply both from the attacker perspective, but then obviously from the defender perspective. And so we've gone ahead and put together a few scenarios where we're going to actually go through how would an attack of this shape, of this ilk, with this kind of access result in potential data theft. But as you think about the Q&A session and we go through this, feel free to bring your ideas or ask what about this. It'd be a fun discussion to have here at the end. So databases offer a ton of convenience. They're really easy to stand up. They abstract away a bunch of the required configuration and scaling and things like that. They can take care of a lot of that for you. But with that, as Dan said earlier, all those niceties come with additional attack services that can be leveraged by the attacker. And so there is no, for example, cloud console to your database when you're running it on-prem. That doesn't really exist. There's equivalents, but I can log into a web page that's accessible from anywhere on the internet and access your database doesn't generally for the most part. So it's one of the things to think about as you think about additional attack surfaces or risk is what happens if someone gets access to the console and what are the ways they could be?
Yeah, and Peter mentioned there's a lot of benefit to sort of putting on the attacker hat and thinking like an attacker would. So for these examples, we're going to play off of that and think about a scenario where somebody has credentials or maybe somebody has an API key for the Atlas platform. What does attacker activity look like once that's happened? And we'll play that out and think about some of the actions they might take and follow on to determine, okay, how can we leverage some of those sources of signal we talk about to detect and hopefully respond quickly to an event like that. So let's put on that attacker hat and think about what we would do once we have access to the Atlas console. Now, by and large, attackers are really looking to get in and get out, get that data as quickly as they can, and that's typically what they're after. So one of the first things I might do as an attacker is try to figure out how I can download a copy of your database. And the Atlas console, on one hand, is very convenient. When you spin up a cluster, you get automatic backups, automatic snapshots. All this stuff is super convenient for reliability. It's also super convenient to me as an attacker. If I need a copy of your database, I can go to that section of Atlas, find your database snapshots, and request a download. So that's probably one of the first actions I would take as an attacker. In Atlas, there's a couple of things that you need to do to accomplish that as an attacker. You request the download link, and for that to be accessible by you, you actually have to whitelist your IP address. You can't just download this from any old IP address. Those are actually two distinct events that we could potentially key off of thinking about how to defend from this type of thing. Additionally, as an attacker, I'm going to want to establish some sort of persistent access to the Atlas service, right? Maybe I get a point-in-time snapshot. Well, let's say I want to come back a month from now and get an updated copy of your database. How would I go about persisting in the Atlas service? There's a couple ways. One, I may just create myself a new user. I may create myself a new user in the Atlas console, which could grant me project or organizational level access to all the clusters, or I could grant myself access to a specific database by creating a new database user as well. So this type of activity is logged in two places. So when you create a new database user via their console, which is very quick and easy, I might add, that generates a control plane event. But you also get an event at the database level if you have already turned on there as well. So again, two opportunities for us to detect that type of attacker activity. So we've talked about two really common things you might do as an attacker, right? Establish persistence, get a copy of the database. When we looked through the Atlas service, we also sort of wanted to look through the lens of a more sophisticated attacker. What might someone who wants to persist for a long period of time, potentially be a little more stealthy, what sorts of more advanced things could you do as an attacker that might fly under the radar, if you will? And one of the capabilities we came across we thought was pretty interesting from an attacker's perspective is Atlas allows you to create database triggers in their console. And those database triggers will respond to events that happen in your cluster. And this is really interesting. As an attacker, I could do something like this, right? I could create a new trigger that responds to an insert on my database, gets the full document, and then in this, kind of simple but silly example here, we'll actually post that full document back out to an attacker-controlled IP address. So this is kind of a cool way of an attacker stealthily, constantly exfiltrating data as it's added to your database in production, which is pretty cool. And unfortunately, in terms of logging, there's not a whole lot of visibility into this. Creating a trigger in their console doesn't generate a control plane event, and you really don't get a clear indication of this happening at the database audit level as well, although there's some tangential events that happen, like creation of the database user and things like that. So let's zoom back out and think about what we did as the attacker here, and think about what sort of signal we could leverage as a defender to clue ourselves into the fact that there's an attacker rummaging around our console. First of all, we stolen credentials, and a lot of times that looks suspicious when the attacker starts to use them, right? So ideally, we would want to identify as a defender when an attacker uses compromised credentials and logs into the platform. Unfortunately, that's not really possible with Atlas today, and this is often the case with many security or database as a service or anything as a service providers these days. Is there's not a whole lot of visibility into authentication into their platform. There's no event stream of logins that we can leverage from the control plane, nothing at the database level or the metrics level. The one caveat is when you log in from a new IP address as a user to their console, the user gets an email from Atlas that says, "Hey, we saw a new login. Is this you?" So there's something there, but again, that's not super helpful from a defender perspective. I want a feed of all my users' authentication activity so I can see when compromised credentials are being used. There are a couple other activities we did though, and the visibility there is a little bit better. So for example, if we poke around a collection, use the data explorer in Atlas to view data, insert data, that's all logged. Adding an IP address to the allow list is logged. Downloading snapshots, creating database users, all that stuff is logged, which is great. And we did hit on the fact that the trigger is a bit more of a stealthy method. Unfortunately, no logs there. So we learned a couple things about what's logged, what isn't. But all this represents kind of a pretty useful exercise, and now we can go kind of apply some of these learnings to those streams of data to try to identify when credentials are compromised in our environment. So we posed this scenario to some people in the community, some of our customers, some organizations using Atlas, and we sort of brainstormed together what sort of things would we do or want to do ideally to address this kind of risk. There's a couple of things that come to mind that I heard, and maybe Peter, you have some things as well. But we heard, of course, MFA, like MFA everywhere. That's a great way to limit access and control access to credentials into the console. You have to also be really careful about those API keys. Those are often highly permissioned, and an API key can mean full access to a cluster very easily, right? I don't know, Peter, if you heard anything else from those conversations.
Yeah, I mean, I think you highlighted the key takeaways is just that cloud console access is unique, and that once they've compromised an account that gives them access, they're able to access it without having to go through your infrastructure, essentially, in a lot of cases. And so it's just good to have an understanding of what telemetry data is available, what signals available, and how to potentially react, or what to look for to react.
Yep. The only other thing I would say is Atlas and many other as a service platforms do have role-based access control. So making sure you're also doing like least privilege helps here as well. So a compromised account doesn't lead to a full account compromise.
And we talked to a number of customers there where the role-based access controls are reviewed at some fixed interval, where there's a calendar reminder that goes off because you have people adding themselves or creating new accounts where they're not following the best practices. And so having even a manual process to review those is going to pay dividends, because you're going to likely catch stuff over the course of doing that pretty regularly.
Absolutely.
The next scenario is a more standard one. It is hey, you have an application. It is using an interface or an API. That is, interface or API is backed by some database, and there's something wrong with that interface or API. There's a bug, there's a flaw, and it's vulnerable. And that is the most common attack scenario we see, at least in the news where it's discussed. And it's pretty common, I think, even it's just probably the most common one out there. And so what we're going to do here is kind of take a look at what what an attack on a vulnerable application accessing a database would look like, and what signals available for us to detect and respond using this scenario.
Yeah, so we wanted to play this one out and sort of be able to put on the attacker hat again. In order to do that, we needed some sort of vulnerable application. So I whipped up a pretty awful application here that I would recommend absolutely no one runs in production or anywhere for that matter, to illustrate what some of these vulnerabilities could look like, and ultimately how we could use, again, some of those sources of signal like metrics and logs to identify attacks. So this is the document viewer 9000. This application allows you to input a query, and it will return documents that match that query and let you view them. There's a couple key things I point out about how this application works that represent some pretty significant vulnerabilities, and they're probably jumping out of the screen here at you if you're an app developer yourself. First of all, we're exposing the database and collection names in the URL, which is not great. So now just by visiting a web page, an attacker knows a lot about how your application works and what the database looks like behind that application. We're also allowing the attacker to directly supply a query string that's just a regex filter on the database. Again, not great, no input sanitization whatsoever. So as an attacker, I can pass any regex query I want, any regex filter I want to this application and get one to all of the documents in that collection. And finally, because again, this database and collection are in the URL here, it's more than them just being presented in the URL. The database and collection are dynamically selected based on the URL. So as an attacker, I can now read pretty much any data from any collection and database that this web application is hooked up to. So again, a little bit of an extreme example, but one that we can use to illustrate what some of these attacks might look like as an attacker. So let's put on that attacker hat again. Again, I'm a real hacker here, so I'm going to use a real hacker tool, namely Burp Suite, and we're going to poke at this application like an attacker might. So a couple things. First of all, we're probably pretty quickly going to understand that the database name and the collection name are exposed in the URL. And by fiddling with those values, I can now change the database and collection that we're retrieving data from. I'm also going to poke at that query string and pass other things like, for example, .star, and pretty quickly realize that now I can return any number of documents from those databases that I want as an attacker. There is a little bit of a limitation here now because we don't have direct interactive access with the database. We don't know, for example, what collections exist. So now as an attacker, I have to do a little bit of enumeration to really find and discover the data that I'm after. I don't know, for example, what the database name is or what the collection name is that holds all that super sensitive information that I really want to get access to. So again, I can use Burp Suite here as an attacker and load up some word lists and literally just enumerate a list of possible databases, possible collections, and try a bunch of stuff until, like in this example, I find the magic combination of, hey, the database name is secret, the collection name is passwords, and it has X many documents. So again, an example of how an attacker might learn or enumerate the database to figure out where that juicy information really lives. So let's put our defender hat back on and take a look at our sources of signal and try to get a sense for what we can use to clue us into that our application is being abused. So first of all, we went to our metrics. We went back to our Datadog dashboard and we saw a few pretty interesting things here. First of all, our read latency, the top left graph here, that spiked pretty significantly when, as an attacker, we were doing that enumeration of all those databases. Additionally, this documents returned metric went through the moon, or to the moon, basically. Once we hit that database and collection, we found it, and we returned all the documents. So that's probably pretty uncommon for your application to issue a query to your database that returns literally every document in the database. That's probably something that's a bit unusual. And finally, along the same lines, we saw the metric for the number of queries spike during this time frame as well. I mean, again, as an attacker, we're guessing a whole bunch of stuff really, really quickly. And so that metric is going to spike up as well. So 3 pretty good opportunities for us to use existing metrics that we already have wired up to develop some security monitors to indicate abuse. We also took a look at the audit logs for Atlas. Again, this is the database level auditing to get a sense for what these attacks looked like from a logging perspective. There's two kind of key behaviors that we were able to pull out here and identify. One is we saw the application user account issue a whole bunch of find commands across many distinct namespaces, which is a pretty unusual behavior for an application. As you think about how your application interacts with your database, it's usually going to be interacting with a fairly static set of databases, collections, or tables, depending on what architecture you're using. But to see that spike and to see in particular a bunch of find queries against databases that we know don't exist, collections we know that don't exist, that's pretty unusual, and that's something that can clue us into application abuse. And then finally, a bunch of commands where the filter is returning everything in the database. Again, pretty highly unusual. So again, kind of summarizing what we saw here, we did a bunch of enumeration. We returned an entire collection. All this stuff is captured in the database logs, but again, you have to know what to look for there and have to profile what your normal application behavior looks like and look for some of those behaviors that might indicate abuse. And metrics actually start to become real useful here. Returning entire database, that spikes a bunch of metrics in Datadog. That's something that we can develop and monitor against. And so again, we had posed this scenario to the security community and some of our customers and had a good conversation around this. And we brainstormed together how we might want to monitor our app for abuse. We talked about a couple things here, metrics to look for, logging behaviors and patterns to look for. Some other common things that organizations brought up would be like, if you've got a web application firewall in your topology, that's a good source for relevant signal in this case. Hopefully you have that in front of your web application and it should be generating some alerts related to this activity. If you've got application logs as well, that would be something relevant to look into here as well. Anything, Peter, that you're thinking I'm missing there?
No, I think you covered bases there.
Cool.
All right, so this will be the last scenario. It's one that we've seen play out a couple times in customer environments, where the attackers actually move to the build server as a way to pivot into production infrastructure. What we've seen in real world scenarios is a lot of build servers kind of accrue technical debt or just CRUD, and some of that CRUD or technical debt is creds left on a build server because they were wiring up the build server and they were making sure that things were accessing prod correctly and forgot to delete the credential file, things like that. So we've seen, and the other thing that we've seen is that the patching of build servers may be slow, especially if it's self-hosted, because it's believed to be kind of self-contained and not facing the internet. But once someone gets into your environment, they can use it as a potential way to escalate privileges into production. So we're going to kind of walk through that scenario.
Yeah, again, this is a pretty much a nightmare scenario for most engineering teams, because your build server often has read-write, and highly permissioned access to your database. And that interactive access is really powerful as an attacker, right? There's a couple things I can do right off the bat. I can just literally, use the MongoDB shell to connect to your database and poke around. I don't need to bother with enumeration. I can just show the database schema with the native commands of the shell. Or as attacker, again, going back to their primary motive, I can just run MongoDB and pretty quickly get a copy of the whole database and exfiltrate that off of the build server. So we did that, and this is kind of what that looks like from a metrics perspective. So we ran MongoDB against our fake application here, and there's really two interesting events that happened. First of all, we talked about project alerts. So the Atlas, service comes with some of these default metrics-based alerts, and we got an email. Like, I ran MongoDB, and I got an email, and inbox showed up and said, "Hey, we saw a lot of documents got returned from this query." That was pretty cool, actually. Cool to see. And going to our metrics, we saw what triggered that, right? Again, we saw this when we did enumeration as an attacker, but seeing that metric for documents returned spike means somebody accessed a significant amount of documents, and that's pretty unusual. And that's probably going to be the best indicator for this type of attack. There's a couple things we want to detect here. Again, database authentication from an unusual IP address, typically those build credentials should only be used from that build server, right? So again, if you saw those credentials being used from a different IP address, that's something that could clue you into those build credentials being compromised or that build server being compromised. Enumeration, poking around with a shell, this is stuff that's going to be really difficult to detect because you've got interactive access to the database. A lot of those operations are not logged. Things like adding users and roles or dumping the database, again, we do have an opportunity via the audit logs or via metrics to detect those types of activities. And again, we posed this final scenario to some organizations in the community and sort of brainstormed how do we want to protect ourselves against this type of attack. There's a couple common themes. First of all, having good EDR visibility on all of your developer workstations, making sure that if one of those workstations gets compromised, you've got visibility into that, and their credentials can't be used to move laterally to the build server. Having some sort of visibility on the build server itself, managing access to the build server with MFA, multi-factor authentication, and just having good visibility and protections around the credentials that exist in that build pipeline, all really important. And so we wanted to kind of round all this out. We talked about a lot of stuff here, and really the theme of this is there's signal you already have today, like in metrics, in database logging, and with pretty minimal effort in playing out some of these attack scenarios in your environment, you can take advantage of that signal and start getting some security value pretty quickly, namely with metrics, with logs. And it's kind of a process that begins there, but there's going to be opportunities to enhance logging, enhance auditing, improve this over time. But we believe with pretty minimal effort, you can start to take advantage of some of those sources of signals that are already out there today.
Awesome.
Cool.
Thank you. Thank you everyone for attending the talk.